Chapter 11, Section 1, Space Figures and Cross Sections. Starting off with a few vocabulary words. A polyhedron is a space figure or a 3D figure whose surfaces are all made up of polygons. Each polygon, so each surface, is called a face of the polyhedron. An edge is a segment, so it's a line segment, that's formed by the intersection of two faces. So these would be two faces. Where they intersect would be the edges. And a vertex is a point where three or more edges intersect. So you can see we have 1, 2, 3 edges. That would be a vertex. So these are all our vertices. Euler's formula is a formula that we use if we have only the number of faces and the number of vertices and we want to know the number of edges, or if we're missing one of them but we have the information for the other two. So Euler's formula tells us that the sum of the number of the faces and the vertices of any polyhedron is 2 more than the number of its edges, so E. So we know that F plus V equals E plus 2. If we subtract V to the other side, we also know that the number of faces is the number of edges plus 2 minus the number of vertices, or the number of vertices is the number of edges plus 2 minus the number of faces. So we can do some playing around with this. You can subtract the 2 to the other side, stuff like that. But this is the formula that you need to know. So in this example, how many vertices, edges, and faces does the polyhedron at this is the bottom left, I changed the position, so at the left, have? And then use your results to verify Euler's formula. So looking at this shape, we can see it has the 2 bases. Here we have 1 base, so 2 6-sided polygons, 2 hexagons. And then we have 1, 2, 3, 4, 5, 6. So we have 6 going around, 7, 8 on top. So the number of faces is 8. The number of vertices, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the number of vertices is 12. And the number of edges, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And we want to show that the number of faces plus the number of vertices equals the number of edges plus 2. So 8 plus 12 equals 18 plus 2. We get that 20 equals 20, so this shows that Euler's formula does work, and it will work for every polyhedron that we come across. So we're going to use Euler's formula in a few cases here. So we have our formula, F plus V equals E plus 2. We know that the number of edges is 30. The number of vertices is 20, and we're solving for the number of faces. So F plus 20 equals 32. We subtract the 20, and we get that the number of faces is 12. Now a cross-section is the intersection of a solid and a plane, so of our 3-dimensional figures and a plane. So the cross-section of this plane and this solid, so of this plane and this triangular prism, is going to be a triangle. So it's basically where are they overlapping, what shape does it form. Here we have this cross-section here, and that is going to be a rectangle. So let's look at a few examples. Now these are examples from your textbook. Number 21 says the vertical plane that intersects at the front and left faces of the cube. So all you have to do is, if this is the front, and this is the left face of the cube. Draw a point anywhere on there, because it doesn't say where they intersect, it just says that they intersect, and connect them. Draw a line down, and a line down, and connect them. And you can see that this is the cross section. A vertical plane intersects opposite faces of the cube. So opposite faces would be like the left and right hand side. So a vertical plane, so it's going up and down, straight up and down. And we would just draw something like this. And you can shade it so that you can see it easier if it makes it easier for you. And the last one, number 23, a vertical plane contains the red edges of the cube. Well, here we can see our red edges, and it's a vertical plane. This is going to be our cross section. And again, if it makes it easier to see, you can shade it, but just make sure it's visible where your cross section is.